Hi, this is our project, exploring lightweight object detection models for wildlife camera traps images. This project is done by Tianhao Zhang, Kexu and Quan Zhou, focused on enhancing object detection methods for ecological researchers. This project aims to evaluate lightweight object detection models for wildlife monitoring using the Caltech camera traps dataset. While YOLO is highly accurate, its computational demands make it unsuitable for resource-constrained environments. We explore alternatives like EfficientNet and MobileNet, focusing on balancing accuracy and computational efficiency to enable practical and cost-effective AI solutions for wildlife research. Our workflow is divided into three parts. First, we establish YOLO as the baseline. Next, we compare YOLO to lightweight models like EfficientNet and MobileNet, focusing on computational efficiency. And finally, we evaluate models using metrics like the precision, recall, and F1 score to identify the optimal solutions. The YOLO is the object detection models for real-time applications. While it excels in accuracy and speed, its high computational requirements limit its feasibility in constrained settings, making it a useful benchmark but impractical for certain applications. The confusion matrix shows strong accuracy for classes like car and opossum, but highlights moderate performance for categories like bird and coyote, with frequent misclassification involving background and visually similar species like fox and coyote. The classification loss, precision, and recall decreases steadily over the training epochs for both training and validation datasets, indicating that the model is effectively learning to classify the object. The consistent decline suggests the reduced misclassification as the training progresses.
For my part, here's a MobileNet. I use MobileNet version 2. Um, the MobileNet version 2 model is a lightweight and efficient convolutional neural network architecture designed for mobile or resource-constrained environments. It is particularly effective for tasks where computational efficiency is critical, such as in image classification, object detection. The MobileNet has slightly lower accuracy than heavier models, limited capacities for complex tasks, and requires careful optimization with other architectures. In a local runtime environment, I used 20,000 images and 20 epics to get the following results. Compare the ResNet and EfficientNet. It seems not a good enough, but for some model of some mobile status, this may be not a bad choice. During making the code, there are many different difficulties like dataset inputs, normalizations, running the code, figure out the environment settings. The most difficult is like adapting to the code with others. We have three different models and different methods to get or deal with the model. Um, to make them in the same code file need more time to figure out and memorize the three tasks. Fortunately, we got the result. We got the result for that and finished the task.
I am Tianhao Zhang. I used EfficientNet in this project, namely EfficientNet B0 and EfficientNet V2S. V2S is an upgraded version with more parameters and higher performance, also with higher computing efficiency. I first used EfficientNet B0. I started from 10,000 pictures and tried batch sizes of 32 and 64, finding out that 32 gave better results. You can see the figures showing the history of loss and accuracy. Then I ran a longer training process of 50 epochs, during which the learning rate reduces to 0.1 times every 10 epochs, so that we can get better stability. After that, I increased the volume of the dataset to 50,000 pictures, which gave better results than 10,000 pictures. And then I used the entire dataset of 240,000 pictures. I got a surprising 99.4% validation accuracy after 35 epochs. However, I found that this might be exaggerated because I mistakenly mixed up the training set and validation set in the process. Finally, I used EfficientNet V2S and trained on the entire dataset for 23 epochs. The final validation accuracy is 97.7%, which is the best result I ever got. And the confusion matrix is shown here, which shows the model works quite well for most of the species.